At modern training scales, AI datasets are created collaboratively by multiple data engineers rather than a single user. In a typical workflow, data engineers independently check out branches from a main dataset, perform data annotation and exploration, and commit their changes. Some branches can be merged via fast-forward merge, while others require three-way merges with conflict detections as the main branches involves. The merged dataset is then exported for downstream model fine-tuning. However, existing systems such as Parquet, Lens, Iceberg, and Deep Lake do not unify these workflows or support collaborative three-way merges. To address this, we propose Muller, a multimodal data lake format for collaborative AI data workflows. Here is our GitHub repository. Let me now walk you through Muller using a Jupyter notebook. First, we create an empty Muller dataset. Then we define the schema and create the columns. Muller supports more than 12 data types of different modalities with different compression formats. We can specify the column type and data type when defining the dataset schema. We then append data in the Muller dataset using the extend interface. We can develop any Python interface to view the data. We also support parallel data ingestions. You may see that in this Cypher10 dataset, importing more than 15,000 rows of image and labels costs around 24 seconds. We also support operating on object storage such as S3 and Roma. You need to provide the credential information like this. Next, we demonstrate data exploration and analysis. We can use the summary and data interface to check the datasets. We also support statistical analysis over datasets or any subsets, such as computing the mean, max, and histograms. So here is another dataset examples. We provide constant time random access and high throughput full scans through NumPy style indexing so that we can check the NumPy array of bounding box and image here. Moreover, we may use any self-developed functions to investigate subset of data or plot specific image with bounding box. So here is a few examples. The data core ring of Muller is based on a vectorized hybrid search engines. So here is a few examples. First examples, we go for XMH and full text merge. So we need to create inverted index on the text columns, then perform different queries joined by different Boolean logics such as AND or NOR. So here is a few examples. So we can also perform full scan, search different keywords using contains, and we can use the offset and limit to control the query range, and we can also use like for pattern matchings. So in these examples, we conduct normal aggregation operations. So in the third example, we conduct vector similarity search, and we create an example here to query 10,000 vectors, and the target query is 1,000 vectors. We show the running results of flat and HNSW index here. The record of vector search is 0.93, and the computation time is fast. Next, I will demonstrate collaborative data annotation using Git live versioning. And here a user check out a new branch def1 from the main dataset, perform data annotation by adding, delete, or updating rows, and then commit the changes. So we can check the log for the commit history. Then another user check out a new branch def2 from the main dataset, perform data annotation, and then commit the changes. So when going back to the main branch, we merge branch def1 and adopt their pop resolutions. So obviously this is a fast forward merge. After that, we plan to merge branch def2, need to check the merge conflicts. So this is a three-way merge with conflict detections. We need the data append in both branches, the pop values in our branches, and the updated values in their branches. So we can view the data in the main branches again. So the result is like this. In another examples, it shows the schema isolation in branches. So based on the main branch, we can create a new branch def3 and add a new columns. Then we go back to the main branch where there are only 3 columns. After merging branch def3, the main branch has 4 columns. So we can check the log once again, and the result is like this. So finally, we can export the dataset into different training-friendly formats such as MyRecord, Arrow, Parquet, or Pandas data frame. So to summarize, Muller provides a unified solution for multimodal storage, expressive querying, collaborative live versioning, and ML-oriented datasets. And to summarize, we believe Muller offers a practical foundation for collaborative AI data workflows at scale. Thank you for watching.